Hello and welcome to the third lesson in sketching parabolas. We've had 2 lessons so far on learning how to look at a parabolic equation or a quadratic equation and noticing the subtle differences between each and how that translates the graph, whether it's up and down the y-axis, left and right on the x-axis, or maybe even flipping or taking the mirror image across the x-axis as well, flipping it upside down. Now today we're going to be having a look at turning point form and working with numbers again to help us solve exactly what the turning point is for each of our equations. Let's first have a look at this. In each of these cases, this is a summary of the numbers that we can put in to our parabolic equation and what they do to each of our graphs, whether it's moving it up and down, left to right, or thinning the graph. Now in this case, if we just get our pen out, if we think about our equations, what does the value of a do? What does that do? Well, if you remember, anything that's at the front of the x, where we multiply it by it, it actually changes the shape of the parabola by either making it thinner or wider. Now the other thing that the value of a can do is flip, because if it's a negative out the front, it can also flip our graph over the x-axis. And that's all that a can do. What about b? Well, b only has one function, and hopefully by now you know that it translates or moves our graph towards the left, but also towards the right as well. And finally, the value of c. If there is a number for c, that also translates our graph, or it moves our graph up or down, depending on whether it's a positive number or maybe a negative number. So this is basically the general form, and any number that is replaced with a, b, or c is going to change how this graph looks according to these definitions. Example number 1. Now example number 1, we are asked to do 2 things. We are asked first of all to determine whether it's a maximum or a minimum, and the next thing we need to do is find the turning point. Now with our maximum or minimum, that's just a way to describe whether the graph is either a smiley face or a frowny face. Just to have a quick reminder, here's our parabola. This is the smiley face version. Notice how it turns around down here, and the turning point is at the bottom of the graph. We call this a minimum because the turning point is the lowest part of this graph. It comes down here, it turns around, and it goes back up. This is what we would call a minimum. The opposite is obviously going to be a maximum, but I'll show you anyway. So when the graph is flipped up the other way and the turning point is the top part of the graph, or it's the largest number of the graph here, so it goes all the way up, it's the highest number and then comes back down again, this is what we call a maximum. Now the easiest way to determine which it's going to be is you have a look at the front of your x values. Remember, if it's a positive number, then it's always going to look like this, meaning it has a minimum. But remember, a negative number flips it across the x-axis, turning it upside down, where in this case it would be a maximum. So negatives make it a max, positives are a minimum. Handy thing to remember. So the other thing we just need to learn then is how to do our turning points. So here's our first equation. First of all, the number in front of the x is a positive number. So we can always say straight away that this is going to be a minimum. Alright, so the other thing we need to do is find the turning point. Now to do this, all we really need to look at is the equation, because the modifications we've made are just going to move the turning point. Remember, the x squared graph has a turning point at the origin of 0, 0, but we've translated it. What's this graph done? It's moved it to the right, remember minus means to the right in this case, by 2 units, but it's also moved it up 1 unit. So the turning point starting at 0, 0 has been moved to the right 2 and up 1. So what could it possibly be? So the turning point, it's been moved across 2. Now if we think about what across is, that's our x-axis. So it's moved to the right 2 units and it's moved up 1 unit. So our turning point is 2, 1. It used to be 0, 0, but it's moved across 2 and up 1. So once you've decided how it's been moved, that's going to determine the numbers that you put in here. Pretty much whatever's written in here is going to be written in here also. Okay, let's have a look at the next one. Oh, first things first, we notice that there is a negative number out the front. Now remember, a negative means that it's going to flip the graph over, meaning, well, it's going to look like this, and it's going to be a maximum instead of a minimum. Now, apart from that, let's see how our graph is going to be affected. Well, the turning point, remember, in the normal graph used to be 0, 0, but it's being changed twice again. First of all, it's being moved towards the left 5 units, and it's being moved down 3 units. So the turning point is going to be, well, if we move to the left, remember that's negative numbers. So it's to the left 5 units, and it's going down 3 units. Now another way to think about it is your turning point can be given by the number inside the bracket and the number that's outside the bracket. Now this number is just copied straight in to your y value. But with the x value, notice that the negatives and positives are around the wrong way. If it's negative in here, it's positive out here. If it's positive in here, it's negative out here. That's a good hint on how to always find the turning point. Alright, let's go to our next question. First things first, we look at the front. There is no minus sign, which means it's a positive number, or if we look at our graphs, it's going to be a minimum. So we write down that it's going to be a minimum. And the turning point, if we have a look at our values, well, it's moving across to the right 4 units. So across the x-axis, 4 units. And it's also moving down or up. That's right, it's moving down 6 units. So the turning point is now at 4 minus 6. Alright, last one. We've got minus 5, and in brackets, x plus 1 minus 8. Now remember, when we put numbers in front of the x, that doesn't change how the graph is going to move. It just makes it either thicker or thinner, or wider or thinner. So this 5 has no bearing on where the turning point is, but this minus sign does change something. And remember, that means that now it's going to be a maximum because it has flipped over. Now a turning point, if we have a look at our graph, it's moved across 1 unit to the left. So it's at minus 1, and it's moved down 8 units, so it's at minus 8. Okay, let's have a look at our next example. Example number 2. Find, if they exist, the x and y intercepts for each of the following questions. Now remember, the x and y intercepts are a little bit different. We're not finding the turning point anymore. We're finding where this parabola crosses either the x-axis or the y-axis. Now if you remember back to linear equations, the x-intercepts can be found by when the other axis is 0. Now what I mean by that is to find the y-intercepts, we are going to substitute the value of x equals 0, because when we cross the y-axis, it doesn't matter where, the value of x is always 0. To show that, if we take any graph, let's just take a parabola. Say it crosses the y-axis at this point here. This exact coordinate where it crosses, it doesn't matter if I move this graph up or down, left or right, the point at which it crosses is always the value of 0 on the x-axis, because if we look at our numbers, this could be like 4, 2. This value right here where it crosses is 0. That's why we can substitute that into our equation, and that will tell us the value of y, where that crosses. Now the converse is true as well. If we're looking for the x-intercepts, we can substitute 0 in for the value of y, and to get our x-intercepts as well. Alright, so let's do that. For our very first question, we're going to have two sides of working out, and they will be when x equals 0 and when y equals 0, and they're going to give our two intercepts. So when x equals 0, we have the equation y equals 0 minus 2 squared minus 1. Now 0 minus 2 is just negative 2. Negative 2 squared is 4, and 4 take 1 is 3. So the y-intercept is at the value of y equals 3. Let's do the other one. Okay, for y equals 0, we would have 0 equals x minus 2 squared minus 1. This looks familiar to something we did in the last chapter. Let's see how this works out. Let's add 1 to both sides. So we've got x minus 2 squared equals 1. Wonder how we can solve it from here. Let's get rid of the squared sign by taking the square root of both sides. So x minus 2 is equal to plus or minus the square root of 1. And the square root of 1 is just 1. So let's add 2 to both sides to finish it off. So x equals plus or minus 1 plus 2, which means that x is equal to 3 or x is equal to 1, because 1 plus 2 is 3, or minus 1 plus 2 is just 1. Now remember how we were solving these equations in chapter 4 and we were getting two answers for x? Well, now you know what you're actually finding. When we solve a quadratic formula, we are finding the x-intercepts of a parabola. So suddenly these values suddenly have meaning. So what have we found? Well, our y-intercept is 3, but our x-intercepts are 3 and 1. Okay, now we haven't been told to draw it, we've just been told to find them. So let's move on to the next question. And we're going to do exactly the same thing. We'll separate our working, and we're going to find the x in y intercepts for each of the following questions. So we'll do x equals 0, y equals 0. Okay, so for x equals 0, we have y equals 2 bracket 0 minus 3 squared. 0 minus 3 is negative 3. Negative 3 squared is 9. And 9 times 2 is 18. So our y-intercept is just 18. Now we'll do the hard one, y equals 0. That is 0 equals 2 bracket x minus 3 squared. Alright, so let's move the stuff over. So we'll divide by 2 first. That's not going to change anything though. So we'll have x minus 3 squared equals 0. Now we'll take the square root of both sides. So we'll have x minus 3 equals plus or minus the square root of 0. Now the square root of 0, well, that's just 0. So we're going to have plus 3 on both sides. So that x equals, well, 0 plus 0 plus 3 is 3, but minus 0 plus 3 is still 3. So we only have one answer. We've got x is equal to 3 or 3. Now what that implies is that there's only one x-intercept. Now you might be thinking to yourself, how can that be the case? A parabola, if we draw it, usually has two. it will go down, but it has to come up again. How can it only have one intercept? Well, that is a very special case where it comes down and its turning point, so where it turns around, is where it touches the x-intercept. So what's happening, if we draw a quick one, is it comes down, it intercepts with the axis, and comes back up again. So it's only one intercept right here at the turning point. So our two intercepts that we have, our y-intercept is 18, and our x-intercept is just 3. There's only one of each. Okay, let's have a look at the next one. Example number 3, we need to do a few things here, so we'll refer back to this slide. For each of the following equations, we need to, first of all, find the turning point, state whether it's a maximum or minimum, state whether the graph is wider or narrower than the x squared graph, and find the y-intercept, the x-intercept if that exists, and then finally we're going to sketch that. So this is the y equals x squared. That's been chopped off for some reason. Okay, so let's have a look at our equation and see exactly what's written. It's y equals x minus 1 squared in brackets and plus 3. So to find the turning point, which is the first thing that we have to do, we have to look at the translations. Now remember, minus 1, don't get confused, means it's going to the right by 1 unit. And the 3 is going up by 3. So the turning point, where it used to be at the origin at 0, 0, has moved to the right 1 and up 3. So our first part, the turning point, is going to be 1, 3. Let's move to the right 1 and up 3. Nice and easy. Okay, state whether the turning point is a maximum or a minimum. Well, that's easy. We learnt from the last example that if there's a minus sign, it's flipped, so it's a max, but if it's positive, it's just the normal one, so it's a min. In this case, it's positive, so it is a minimum. Okay, looking back. So number 3, state whether the graph is wider or narrower than y equals x squared. Well, looking at this equation, there's no actual number in front of our x term that we would multiply it out by. So in fact, it's not going to be wider or narrower, it's going to be the same or no change at all. Okay, let's have a look at D. What's the next thing that we had to do? Find the y-intercept and the x-intercept. Let's do that all in one go. Remember, from the last one, we just set up our table and we do our x equals 0 and our y equals 0. So, if we substitute those values in, for x equals 0 first, we would have 0 minus 1 squared plus 3 equals y. Or minus 1 squared is 1 plus 3 is 4. So y equals 4. So we've got our y-intercept, and this will be part E over here. Our x-intercept is x minus 1 squared plus 3 equals 0. So minus 3 off both sides. X minus 1 squared equals minus 3. Square root both sides. So we have x minus 1 equals plus or minus the square root of minus 3. And then we add 1 to both sides, so x equals plus or minus the square root of negative 3 plus 1. Now we've come across a problem because we can't actually take the square root of a negative number. So what did that imply? Think back to chapter 4. If we were trying to do the square root of a negative number, that meant that there were no real solutions. Meaning that for this example, there is no x-intercepts for this parabola. Now that's pretty straightforward. That just means that the turning point is above the x-axis and it doesn't cross at any point in time. Alright, the last thing we had to do once we found the intercepts, if they existed, was we had to sketch the graph. So using the information that we've been given, we can actually now go back and sketch it all. So first of all, the turning point we can label as 1, 3. So let's go and find that. 1 and then up 3, here's our turning point. Now we know it's a minimum, and it's not fatter or thinner than a x squared graph. We know that the y-intercept is at 4, so it crosses the y-axis at 1, 2, 3, 4. And that's all the information we know. So when we sketch it in, we come down, we make sure we hit these 2 points, it turns around, and then goes back up again. And we'll label in our turning point of 1, 3. We'll label in this as being 4. We've got our axes labeled, and that's all we can really do. Now the next example, I'll save a bit of time so you don't have to watch too much more, and I'll let you do that by yourself, but I can tell you that there's going to be a little bit of difference between this one and the next one. First of all, there's probably going to be some x-intercepts, and second of all, let's have a look at the equation up here. So this is going to change because it's going to make it, which? Thinner or wider? One of those two. And maybe it's going to have some x-intercepts as well. We'll soon find out. Okay, I've been Mr. Rappell. I hope this has been informative. Please let me know if you're struggling with some of the stuff that we do in this chapter, and I'll see you in class soon. Have fun. Bye.